Now that we've talked about extractive and compressive summarization, we're now going to turn our attention to abstractive summarization in this segment. So let's look at a sort of attractive approach to summarization that we could maybe build using the Seq2seq approaches that we saw earlier in the course. So maybe we just want to take a whole article, feed it into an LSTM, and then, like we were doing in machine translation, just crank out a summary from our decoder. So basically think of it about it as a translation problem translating from an article into its summary. So most of what we're going to look at in this part, by the way, are going to be single document methods because you need a lot of data in order to train this stuff, and we don't have that many data sets which consist of big document collections. Regardless, this is an approach that we could try to take, and we're going to see what some problems are with it and how we might modify it in order to fix that. So the primary thing, by the way, that makes this challenging is the fact that a document is really, really long compared to a sentence. And so all the problems with LSTMs, and even if you introduce transformer models, there's a lot of challenges handling these long contexts, both computational as well as sort of inferential in terms of how the model can figure out what correspondences exist between the input and the output. So what some of the earlier work on this task looked at was the task of headline generation. So the site in the bottom is not correct. This should be the Chopra et al. 2016 from the previous slide. The headline generation task consists of taking the first sentence of an article and then generating a headline based on it. So what that looks like is this, where the sentence talks about Brazilian defender Pepe is out for the rest of the season, and then the reference here is football, Pepe out for season, and a Seq2seq model might generate the following: Ferreira out for rest of season with knee injury. Okay, not actually too bad, right? It's got some bit about the knee injury, but it's got the wrong person being out for it, right? So this can actually work decently well, and if you incorporate attention and some other tricks, it kind of fixes things up. But what happens if we try this on a longer article? So here's an example of a much longer article that we're going to feed into a Seq2seq model and use a Seq2seq plus attention model like we saw on the previous slide. And so what are the problems here? Well, there's a bunch of them. The first is these unknown words. Unc says his administration. So this was something that could never happen in an extractive model, right? Because we would always just get the words in the original sentence. His administration is confident it will be able to destabilize Nigeria's economy. That doesn't sound quite right. And in fact, if you look up above at this second or third blue highlight about halfway down, he said his administration is confident it will be able to thwart criminals. All right, that's very different than destabilize Nigeria's economy. This is one of the big issues with this type of summarization, is that it might just lie to you. And so we'll talk about this issue in a future segment, but for now, the main issues are that it's just really not respecting the structure of the input here. And so Abigail C. et al. From Stanford looked at a pointer generator model similar to what we saw when we talked about copying in the case of semantic parsing and machine translation. So what they've got here is source text on the lower left, the input article, and their summary on the lower right, and then they predict two distributions. They predict the distribution from the vocabulary, that's from the standard sequence-to-sequence model, and they also predict a copy distribution, and then they mix these together with a mixing weight. And that gives you this final distribution in the top middle of the slide, which is going to make it much easier for the model to copy tokens, and will also enable it to copy tokens that we've actually never seen before and aren't in the vocabulary. So this model, which again is similar to stuff that we've seen before, is nice in that it allows us to fix up a lot of these issues. It basically turns the summary into something that's a little, significantly more factually correct and understandable. And then they have an additional mechanism for integrating a notion of coverage. So basically, we want to talk about different concepts, this marginal relevance idea. Don't talk about the same thing multiple times. And they integrate that, and it leads to further improvements for this bottom summary. So this is a nice approach. The main challenge here is that this approach is not actually as abstractive as we might want it to be. So one nice thing they studied in their work was the fraction of 4 grams, well, 1 grams, 2 grams, 3 grams, and 4 grams, but we'll focus on 4 grams, that are novel with respect to the input document. And so their pointer generator plus coverage model actually only produces around 10% novel 4 grams. And so that means that 90% of the 4 grams in their summaries are taken directly from the original article. And this is out of whack with what is true in reference summaries, right? This green bar is much, much higher. Around 80% of reference summaries are, reference summary 4 grams are novel with respect to the original article. And basically what's happened is that in trying to fix the sequence-to-sequence model, we've reconstructed an extractive model. And so maybe that's okay. We've made an extractive model with a little bit more flexibility, but then it also needs to be trained on a lot more data. It can still lie to you. There's all these other issues here. So this is going to set us up for talking about pre-training and summarization. And we're going to see that pre-trained models do a better job of introducing new content while also staying factual. And by new content, I mean doing this kind of rephrasing and expressing things a little bit more naturally, while they also stay, reasonably faithful to the original article. But spoiler alert, there are still going to be some factual errors in them, and understanding how to generate text that's factually correct with respect to the input is a big ongoing research problem these days. And that's the end of this segment.